Electron affinity is less predictable, but I like to talk about it because it's the opposite of ionization energy. It's the energy associated with an addition of an electron. So notice that atom gaining an electron so that it becomes a -1 anion. And the energy associated with that, we call it electron affinity, and they will always, or most of the time, be negative, releasing energy. Some may be endothermic, and this is why this topic is not as easily accessible for us in this class. We won't use electron affinity that much, and we'll see some numbers and show how they're really not helpful at all. The more energy that is released, what we do call that is a larger electron affinity. That's another reason why it's not as fun. The more negative the number is associated with that energy, it's negative because it's being released. We call that a larger electron affinity, means that that atom loves electrons a lot. So here's the chart. In general, electron affinity increases as you go from left to right on the periodic table. What that should tell us is that metals do not like electrons. Nonmetals love electrons, which makes sense. Nonmetals tend to form those negatively charged ions, right? We love electrons. Here's my heart. And nonmetals tend to form +1s, or metals tend to form +1, +2. We don't really care for electrons. We'll say it nicely. We won't use the word hate here. I don't like to spread that out into the universe. Halogens have the highest electron affinity for any period. They love electrons. They want one more electron. They're going to try their hardest to get that one electron to reach noble gas phase. They're so close. So electron affinity becomes more negative as we move from left to right, meaning that more energy is released as we move from left to right. We don't really want to talk about going down a group. What we tend to see is, it starts to look like it decreases, like there's a more positive value. But let's just, look at these abnormalities. Yeah, they're very weird. So we don't talk about going down a group or a family at all. Has a little bit to do with size. It has a little bit to do with the valence, but we won't talk about them. Now, the last periodic trend we have is metallic character. Metallic character tends to increase as we go down a group. Why? It's because, again, the atoms are getting bigger. It's because ionization energy is decreasing. So there's a lot of reasons for that metallic character. The most important two trends I want us to know are the first two, atomic radii, and first ionization energy. Metallic character kind of makes sense with the idea of ionization energy. Metallics meaning making cations. So if it's easy to make a cation, then it means it's a very good metal. That's pretty much it. Electron affinity, there's no definite trend moving down a column. That's why you see a blank there. But moving across a row, you see that there is that general trend of decreasing, more negative. Lovely. So this chart of summary of the periodic properties you should know, but the first two you should know intimately. You should know the reasons why in terms of Z effective or the size of the orbital. And that's all I have for you today. Thank you so much for joining me.